Howdy, if you're looking to make a do-it-yourself Slayer Exciter, or you're simply interested in knowing how they work, you've come to the right place. If you don't know what a Slayer Exciter is, you might think it's some sort of hard rock cover band from the 80s. It's not that. It's a Tesla coil capable of producing extremely high voltages. This video will cover everything, yes everything, that you could ever want to know about a Slayer Exciter circuit. Everything from the physics to how to build it. First, I'll be going over the commonly used schematic for a Slayer Exciter and explain the physics behind it. Then, I'll demo the construction of a Slayer Exciter for you with a step-by-step tutorial. I follow that up with a demo of the circuit in operation to show off some of its physical implications. Finally, I have a few ideas to make it far more powerful. So feel free to jump ahead to any of these timestamps or the ones down in the description. Now, without any further ado, let's get into it. Let's start by looking at the most commonly used schematic, which I imagine is what most of you are interested in. The schematic may look a little confusing if you're new to electronics, so let's break it down. This symbol here represents a battery, usually 9 volts and up for this type of circuit. Here we have a resistor with a rating of 47 kiloohms, though it could be a little higher or lower. This symbol here represents a transistor, which is a switch that can be turned on and off electronically, and these loops here represent coils. Although we don't draw it that way, the taller coil is actually inside of the shorter coil. So this setup is what is called a resonant transformer. A transformer is a means of stepping up an AC voltage on the primary coil to either a higher or lower voltage on the secondary or output coil. When current goes around a coil, it creates a magnetic field through that coil. This is called an electromagnet. Now, the reason that one coil can create a current wirelessly in another coil is thanks to a physics principle known as Lenz's law. The concept behind Lenz's law is that a coil of wire will resist the change in a magnetic field. Thus, when the transistor is closed, allowing current to flow through the primary coil, for a short time, since the current change is not instantaneous, the magnetic field is increasing from 0 to some field strength. While it is increasing, the secondary coil will resist that change with a magnetic field in the opposing direction, meaning that a current will start to flow in the opposing direction in the secondary coil. This means that the direction that you wind the coils does matter, and you want them both to wind in the same direction, but we'll touch on that again in a minute. We want the current created in the secondary coil to be tied into the gate of the transistor, which means that every time the secondary coil goes high, it pulls the primary coil low, and this will cause the circuit to begin oscillating all by itself. The gate is switched by the current through the resistor from the battery, closing the switch and allowing current to flow through the primary coil. When it induces a current in the secondary coil, a countercurrent turns off the transistor, thus opening the circuit for the cycle to begin again. The beauty of the Slayer Exciter circuit is that because of this, the frequency is self-regulating. What I mean by that is that the circuit resonates. Think of resonance as pushing somebody on a swing set. You don't just want to push them whenever. The best time to push somebody is when they reach their peak. This is where maximum power can be transferred into the system. Likewise, the Slayer Exciter circuit is designed to push more current just as the magnetic field is collapsing, just like a swing set, and this allows it to come very close to the resonant frequency of the circuit. Wow, where did all those Saturday nights go? Now that we've got all that pesky science out of the way, we can finally start building our Slayer Exciter. So, here's how I did it. So here's all of the components that we're going to need in order to build this thing. We're going to need a power source. This could simply be a 9-volt battery, or a power supply would probably work best. A 47 kiloohm resistor, a TIP31C NPN transistor, and for the primary and secondary coils, I used 10 gauge and 30 gauge wire respectively. Once we have all of our components sitting in front of us, we're going to need to connect them together. Here's a diagram that shows how all of the things that I'm using connect together. So I finished up soldering my board and it looks like this now. Before you use it, double check it to make sure that you've assembled it correctly. Otherwise you're gonna find that all the components are gonna start blowing up like a bowl of beans in the microwave. So now that I have the PCB board securely attached to the plate, next it's time for the secondary coil tower. To make the secondary coil tower, I wound 30 gauge wire around a 1.5 inch diameter PVC pipe. Hey, if you need a pickup line, try this. Like 30 gauge wire, you're fine. But I'm a famous YouTuber! I'm alone. Since my secondary coil has about 1,000 turns of wire and my primary coil has about 4, that means my voltage step-up factor is 250 times the input voltage. Meaning if my input voltage is, say, 20 volts, that means that my output voltage would be a whopping 5,000 volts. I taped off the ends so that the entire thing doesn't unravel. Finally, I sandpapered the edges so that I can actually connect them into the rest of the circuit. Next is to attach the base of the coil to the gate of the transistor, and to do that, I'll just put these matched wires side by side and use a wire cap. There we go. So for my primary coil, I wrapped it around a PVC pipe so I could get approximately the right dimensions. Now I made more windings than I'm ever going to need so that I can clip onto it at different points and vary how many windings I have depending on where I clip on. So where I have it here is at about 3.5 turns on the primary coil. I find that this is the best compromise between stepping up the voltage and having a strong enough magnetic field to move sufficient power. But be sure to experiment around with that yourself, because that's just what works best for me. Finally, we need a transistor to oscillate. A lot of people use the 2N2222 transistors, but I find that they're just a little too small for this kind of application. So my preference is the TIP31C transistor. These are pretty high powered, relatively speaking, and they have a very fast switching speed. I bet we could get a better look if I taped it down. Well, that's unfortunate. Thankfully, replacement transistors are pretty cheap. So this begs the question, why are all the transistors heating up and burning out? The answer is actually quite simple. As we mentioned earlier in the video, the secondary coil is only drawing power from the primary coil while the voltage is changing, or while the current is going from 0 to some value. But if you take a look at the waveform of this circuit off the oscilloscope, you see that the current is only changing for a small amount of time, and then it plateaus. While it's plateaued, that is power being wasted, which means that that's going into generating all of the heat and inefficiencies that your circuit is experiencing. So how do you get around this? Well, I just put a whole lot of transistors in parallel with one another. That way, every time I add a new one, it divides the current by how many there are, and therefore each individual transistor heats up a lot less. Let me show you what happens when I plug the mega transistor into the slot here on the board. And now that our input circuit can handle a lot more power, we can crank up the voltage even higher. And this is our new output. And now our entree is done, and we can sprinkle on assorted electronics to taste. Alright, we've made this Tesla coil, but now what can we do with it? Well, I think you're in for a shock. I know, my electrical puns are always so current. Hey, I can keep going. You'll laugh until it hurts. Well, I tried. Bad electrical puns aside, may I present to you the Slayer Exciter. Tesla coils are a pathway to many abilities some would consider to be unnatural. Although we cannot see it, there is a strong alternating electric field that can knock electrons out of the mercury vapor inside this fluorescent lamp, and when the field reverses and the electrons come back to the mercury atom, a photon is emitted. Now, although this photon isn't in the visible range that we can see, it interacts with a phosphor, that white dust coating the inside of fluorescent lamps, and this causes it to glow in the visible range. In fact, you can see a similar effect with the noble gases inside of any sort of incandescent bulb. And no, this is not giving you cancer. There is a lot of energy here. I know it's hard to believe considering how small of an input power we have, but what you see on the output is actually the air being ionized and turned into another state of matter called a plasma. It just so happens that plasma is crazy hot. But instead of just letting all of this charge bleed off into the environment and ionize the air, there is a way that we can allow the charge to build up so that we can get an even greater power output. How? Well, we can slap a top load on top of the Slayer Exciter. Like this. By putting a top load on top of the Slayer Exciter, you can allow more charge to build up, which means that you can get more powerful arcs. So then I'll just put it inside the top load and simply tape it down with a piece of electrical tape, and that's it. Our top load is now installed. More than just giving a Tesla coil its distinctive look, a top load actually adds some functionality to the Tesla coil by allowing it to hold more charge and dissipate more. And of course it transfers a little bit more power too, so don't touch any metal that you're holding near this. Ow. That was my pinky, man. This top load presents me with the perfect opportunity to test something I've been meaning to show y'all. So if I set this on top of the top load, such that now I have each of the ends of the wire pointing away from each other like this, it should create a spiral motion around the top load. Let's see. I used to think that it was the electrons being shot out of the ends of the wire that caused it to rotate like this, but upon thinking about it further, I realized that electrons have almost no momentum. What's happening is the electrons are heating up the air, and the hot air is what's pushing it forward. And I'd say that concludes the final experiment. Okay, one more time. Well, you've made it to the end. I know it can be a little dry at times, but I hope that by now you understand all of the ins and outs of this Slayer Exciter Tesla Coil circuit. Well, that's all I got. Remember to stay safe and have fun.